Hey guys, welcome back to part 2 of the basic organic chemistry you need to study. And in the previous video we were talking about organic molecules called hydrocarbons. And hydrocarbons are the basic units of organic chemistry. They are the very basic backbones that we see in many different organic molecules inside our body and in general all over the world, all over nature. And we didn't talk about how to name the organic compounds, the hydrocarbons. So hydrocarbons have a very straightforward way to name them. So in organic chemistry we use something called nomenclature, and in nomenclature we have a specific set of rules that we are using in order to name different compounds. I'm going to give you the very basic ways to study and to name hydrocarbons, and in the future where we're actually going to study organic chemistry in depth, we are going to touch all of the names and all of the nomenclature. But right now I want to give you just a specific example, a very basic example of how to name different hydrocarbons, very basic hydrocarbons. So let's draw and understand the following formulas for the following carbons that I draw right here. So when it comes to a single carbon atom, we know that we are going to have 4 connections, 4 covalent bonds with hydrogen around it. And we have a single carbon right here. Now we have 2 carbons. So we know the same, each one will contain 3 hydrogen around it because we already have 1 covalent bond in between the carbons. And now we reach a point when we have a saturated hydrocarbon with 2 carbons as a backbone. Now we have this one, the 3 one. We can just saturate it with many different hydrogens. Now we can see that we have a saturated hydrocarbon with 3 carbons in the backbone. Let's type 3. Now we have 4. The same. We have 4 carbons in the backbone, and everything is surrounded by hydrogen because the molecule is saturated. But how do we name them? So in order to name saturated hydrocarbon chains, we use something called nomenclature, as I said in the beginning of the video. And saturated hydrocarbon chains go in this under specific umbrella of molecules called alkanes in organic chemistry. An alkane is an hydrocarbon, a molecule that is made from only carbons and hydrogen, which doesn't contain any carbon. They all don't contain triple or double bonds. They are completely saturated. And the alkanes can be named based on the amount of carbons we have in the backbone, in the longest backbone. So check this out. Here our longest backbone. Let me change the color so you will be able to see it better. For example, here our longest column, the longest carbon backbone is 4. Here the longest one is 3. Here is 2, and here we have only 1. So we have a set of names we can use based on the amount of carbons, the number of carbons we have. If we have 1, we name it methane. So it's divided into meth, which is 1, and ane for the alkane. This is why it is named alkane. If we have 2, it is called ethane. So the ane again is for the alkane, the eth for 2. If we have 3, we call it propane. Propane, as I mentioned in the previous video. Ane is for the alkane and prop is for 3. If we have 4, it's going to be butane. The same concept, so ane for alkane and but for 4. And we can just keep going and going all the way to billions and billions of alkanes. So how do you name alkanes? How do you name saturated hydrocarbons? based on the number of carbons they have in the longest back bond. But wait, let me show you something interesting. When it comes to hydrocarbons, for example, butane, we can write it C4H10, because as you can see we have 4 carbons and 10 hydrogens. 1, 2, 3, 4, 1, 2, 3, 4, and another pair. But we can also organize it in different way, and it is still going to be called C4H10. Let me show you what I mean. So if I take this methyl group, as we said, methane, methyl, only a single carbon and some hydrogen around it, and we take it to a different place on the molecules, for example, like the following. Now we still have C4H10. We still have 4 atoms connected to each carbon. We still have 10 hydrogen. We don't have any triple or double bond, but it looks different. What does it mean? What is the significance of the same formula but a different structural formula? What does it mean? So in the future, when we study organic chemistry, you will understand that the orientation and the structure of the molecule give it different properties. For example, boiling point and melting point, it varies between the different molecules, depends on their structure, even though they have the same formula. And the fact that they have similar formula but different structural formula, this is where we say they are isomers. So isomers is when you have the same formula, in our case C4H10, but in space the structure is different. Where you draw it down, when you see it under the electron microscope, the structure is different. The carbons are connected in different way. But in this example, our longest hydrocarbon, our longest carbon chain is not 4 anymore. We don't say it's butane. It's not this one with 4 carbons. So how do we name it? How do we know how to name the same formula but a different structural formula? So in order to name it, you just find the longest carbon chain is either this or this, and you have 3 carbons. And I will teach you in the future how to actually understand how to find the rest of the nomenclature. So right now I will just give you an example, but don't be overwhelmed because I'm going to explain everything in future videos absolutely. So we find the longest carbon chain, and then we find the extra things that are attached to the carbon chain. So in our case we have a methyl group, a methane, but a methyl group. When you have a specific group and not only a hydrocarbon, it's called it gets the suffix "il". So we have 1, 2, 3 propane with a methyl group. So what do we get is methyl propane. But don't let it overwhelm you. We will study the nomenclature in the future. Just remember for this lesson that you have different structural ways to represent the same formula. So C4H10 can have 2 different ways that you can represent it in the structure. And we have the longer and the bigger the molecule gets, the more complicated and the amount of structural isomers can occur. So for example, if we have propane, you would only be able to create a single one, a single isomer. It doesn't have any isomers. If we have butane, as you saw, we're starting to get two ways you can have the same formula but different ways to orient it in space. And the more carbons you add, all the way to 30, you suddenly see we have a lot of ways to we have so many isomers for the same formula, for the same hydrocarbon. The hydrocarbon is just oriented in space differently. The carbons are connected to each other in different ways, which gives us a different isomers, but the same formula, the same C30H62 in our case. So it's something that is very important to remember. And I hope this video made sense. I wanted to teach you guys what are isomers and the basic way we give names to different organic compounds, even though in the near future I'm going to teach you write an appropriate lesson where I show you the steps of how to name organic molecules. Right now, just remember saturated, unsaturated, isomers of hydrocarbons. I hope this video made sense and I will see you next time.